Hi there, Mr. Thompson here with a video math lesson talking about Pythagoras Theorem, or often referred to as the Pythagorean Theorem. Now, before we talk about Pythagoras Theorem, we have to talk about the scenario in which it works, and that is with right triangles, or sometimes referred to as right-angled triangles. Okay, so what is a right triangle? Well, probably not too unfamiliar. Right triangle is a triangle that has a right angle, okay, or a 90-degree angle. Okay, that's what a right triangle is. And there's some terminology we need to figure out here. Right triangles can come in all shapes and sizes. They just have one thing in common. First of all, they're a triangle. They have three sides and three angles, three vertices, but they have some specific parts. First of all, they have this one angle is a 90-degree angle, as we've said, okay, and it gets labeled with these little boxes, right, that identify that angle as the right angle, okay. And then we have each side has kind of a name, okay. This side here is called the hypotenuse, okay. A lot of people say, oh, that's the longest side of the triangle. Well, it is. It turns out it is. But the way we define the hypotenuse is not from the fact that it is the longest side. Hypotenuse is defined as the side of the right triangle that is opposite the right angle. Okay, we can see here it's across from. Opposite basically just means across from the right angle. Okay, none of the corners on the hypotenuse, the ends of that hypotenuse, are the right angle. It's the one that's opposite, across from it. Same thing down here. This would be the hypotenuse here because it's across from the right angle. Okay. Next up we have the legs. Okay, both of the other legs, the other sides of the triangle have the same name, the legs. Okay, and those are the shorter sides. Sometimes they're equal in length, sometimes they're not, but they're both called legs, and they are defined not as the shorter sides, but as the sides of the right triangle that are adjacent to the right angle. And adjacent basically just means next to. Okay, so we can see here these legs are right next to, on either side of the right angle. Those are the legs. Okay. All right. Now that we've got that terminology figured out, we can talk about what the Pythagoras Theorem actually is. And it's a bit of a mouthful when you write it down in words. Okay, but we'll simplify it hopefully, and we can make sure we understand it. Okay, but let's read it. It says, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the legs of the legs. Whew, lots of stuff there, lots of ofs and bits and pieces here. So let's break it down. First of all, we're talking about a right angle triangle. Okay, we've got a right triangle, we've got a right angle. We have three sides, and I've labeled these sides. We could, of course, label it leg and leg and hypotenuse, but those are big words, and we like to use just symbols. So I've got A, B, and C. A and B are the legs, and C is the hypotenuse, and you'll find that that's, if you keep that consistent, it doesn't matter which leg is longer or shorter between A and B, they're interchangeable, but the hypotenuse we always do as C, okay, so to keep that straight. And what this big jumble of words here boils down to is a simple equation. Okay, first of all we have the square of the length of the hypotenuse, so in this case that is C, so we have C squared because it's squared. Okay, the square of that hypotenuse is equal to, so we just put an equal sign, the sum, so that's adding, the squares of the lengths of the legs. So we're going to take A and B, we're going to square them and add them together like so. Okay, so C squared equals A squared plus B squared. It can also be written as A squared plus B squared equals C squared. Either way, it doesn't matter. You're just flipping around the equation, and you'll see it both ways different times. Okay, when you're looking for the hypotenuse, it's good to have this one, have it written like this, and later on in a different video I'll talk about finding the legs, and it's good to use this one in that case. Let's look at an example real quick. Okay, find the length of the hypotenuse of the following right triangle. Here we have a right triangle. The legs are 5 and 12, and we don't know the hypotenuse, we just labeled it C. Okay, so we know we have our C squared equals A squared plus B squared, our formula for the Pythagoras Theorem. And what we're going to do is plug in the bits that we know, okay? We're going to write this formula, but instead of A, we're going to put 5, okay? And instead of b, we're going to put 12. Okay, now it doesn't matter. I could have put 12 here and 5 there because we're just adding them, and when you add things you can do it in either order. So between a and b it doesn't really matter. Typically a is used to represent the shorter one, but it's not a big deal. Okay, so now we just simplify this. So 5 squared is 25 and 12 squared is 144, and so we add those together and get 169. So we have an equals and a number, but that's not our answer, because what does this equal? This equals c squared, right? And we want to find actually c. We want to find the length of that hypotenuse. We want to find what c is. So we have to get c by itself. When c is being squared, to get it by itself, we take the square root of both sides. Okay, and the square root of c squared is c. So that solves this problem. And we do it to both sides. So we do the square root of 169, which is of course 13. Okay, so our answer is 13. Now, hold on, sorry, let's go back. This is a nice, easy round number. The square root of 169 is a nice, easy 13. Okay, but sometimes it doesn't turn out quite so simple. So let's look at a different example. Okay, I'm just going to do I'm just going to rub out that 12, make it 11. Okay, and then this becomes 11. Okay, 11 squared is 121. And 25 plus 121 is 146. Okay, now 146, unlike 169, 146 doesn't turn out to be a nice easy number. It's somewhere between 12 and 13, right? Because the square root of 144 is 12, and 169 was 13. So this is going to be somewhere around 12. So basically, there's two things you can do here. You can plug it into your calculator and round it if the instructions, which we don't have any instructions about rounding, but often your textbooks and things like that will tell you what to round it to. Okay, and in that case you can just plug it into your calculator and round it as required, which is what we'll do here. Okay, it's about 12.08, so close to 12, which makes sense because 146 is close to 144. But some instructions might say find an exact answer, in which case you have to simplify this radical. Okay, underneath this square root, you might need to find what's called a surd. Okay, an exact value for this square root. I'm not going to go into doing that. If you are asked to do that, you might need to look up another video. I'll probably make a video on that eventually, but for now you can probably just Google it and find another video on how to do that. Okay, so that's all for now. I'll make another video very shortly about finding the shorter sides of the triangle when one of these legs is unknown, and if you know the hypotenuse. So stick around for that. If you need to learn how to do that, good luck, and we'll see you next time.